Welcome everybody to the talk about testing patterns with AM as a cloud service. My name is Barry. I work for AmeXio Group. I'm a software engineer. I'm here with my colleague Koen. He's also a software engineer, and we do consultancy for multiple AM projects. So let's start with the basics. Why are we here in this session? We all know that Adobe provides an archetype, which you can use as a starting point, and also Cloud Manager if you want to deploy your code, test your code, and see that you get the quality gates that are present and are adhering to the best practices. While using those, we noticed that sometimes tests were starting to fail only on the development pipeline, and we saw that the developer experience was really low. Another thing we noticed is that sometimes quality issues are very late, spotted very late in the process, and we wanted to change this by adjusting some tweaks to the archetype. So we introduced some new concepts, and we wanted to share this with you. So what are the requirements for the changes to this process? The most important thing is that we want to detect quality issues as soon as possible in the development chain. What we also want to do is keep aligned with Adobe's best practices, of course. And we want to avoid that issues are being merged into the stable branches. So for example, if you're doing local development, we want to failing test there as early as possible. If you are hitting Sonar Cube issues or whatever, we want to shift that as far as possible to the left. Another thing that we always try to keep in mind, because we work for different customers, is we want to keep our setup vendor agnostic. This means that we don't want to rely on vendor tooling with license costs, and we want to create a minimal setup that works for every project. And of course, that the implementation is repeatable, so we can share it across projects. Also, if you're on a different project, that you have the same quality assurance to get code into production as fast as possible. Important to know for this talk is how the code flow. Many of you might already know this, but for example, if you're using a branching flow, like with a production branch, a development branch, and a future branch, typically if you're developing with your local SDK, you're using a develop feature branch, and if you want to deploy to the cloud environments, you have a respective branch that is picked up by the pipelines in Cloud Manager. Here, for example, the development pipeline picks up the development branch, etc. How does this look like if we deploy this code? If you're working locally and you start with the archetype, of course you're using Maven, and then you're deploying to your local SDK. The same goes for the deployment in the cloud service environment. You have the Cloud Manager, which picks up your development pipeline to the dev environments, and the production pipeline goes to the staging, and then to the production environment. This should all be known. Also, you have a code quality pipeline. A code quality pipeline can also be configured in Cloud Manager. The only drawback here is that it's a static branch that gets assigned. There's no branching patterns or whatever, but you can still use it to detect issues on your feature branches. So let's zoom in on the actual development pipeline, and it's important to know this, to know what we're missing and how we can shift this to the left to get these steps succeeding with a great guarantee. So at first there's a Maven build, which does a build, which is the actual compilation of your code. It runs your unit tests, typically with AEMaaCS, etc. Then in the next step, there is the code scanning phase, which uses Sonar Cube of Adobe, where we don't have the rule set. If that is all great, then the code is deployed to the dev environment on your cloud, and afterwards, all the test suites are being run. You have the product functional tests, for example, which are maintained by Adobe, and then you have your own custom functional tests that you can provide. Other than that, you have your custom UI tests, for example, with Selenium or Playwright, and afterwards, you can do an experience audit, or the pipeline will do an experience audit using the Lighthouse tooling. So if you compare now the local flow with Maven and the development pipeline, if you compare what is in the archetype versus in the pipeline, you see that there are 3 phases where it can actually fail. You have the experience audit, which can fail. You have the product functional tests. All those can fail. And also, not all tests are being run. Another thing that can happen is, as you saw, if all checks are okay, deployed to the development environment already is happening. And if it fails there, then you might have some broken dev environments. So the issues for us with the default setup were that sometimes we see that we were merging code. It has a failed test on the dev environment, or the dev environment is unstable. Sometimes we're hitting Sonar issues, which are not spotted in the local development, but we first have to do a build on the code quality pipeline. And another thing that we noticed is that sometimes specific functionality is not available in the local SDK, and that is not representative enough to run specific tests. you might think the RDE, as spoken before today, it might come to the rescue. It might come to the rescue for the feature parity, but for your testing strategy, it doesn't solve it. And what we did is we were inspired by the talk of Adobe last year with the CI/CD with the RDEs, and we built further on that to see what we need to change to make it workable for us. So what we did is we want to present you with our RDE testing approach. So the PR pipeline that we introduce is doing two things. First thing it does is it uses an RDE, and we fully automate this setup that if you are contributing code, before it gets merged, it will run all the test suites. It will run the tests with AEMaaCS, it will run your ITE tests, all the product functional tests are also run, the custom functional test, etc. Everything is being run, and in that way you're sure that if your code gets merged to a develop branch or a stable branch that goes to an actual cloud environment, that you have less chance of failures. What did we learn during this process? The first thing we learned when working with RDEs is that you always have to reset it before running your tests. You always want a clean and isolated environment, and sometimes it can happen. For example, if your Maven build fails or a specific test before the deploy fails, you don't want to always reset your RDE. So we're using the AEMaaCS CLI to check the bundles in a config. If there's no custom code or config, of course you don't need a reset, because the reset takes about 5 or 10 minutes. Another thing we noticed during the process is that actually the status command of the RDE is not very reliable. So what we do is after we deploy all custom code, we check the homepage for 200, for example. Another important thing to have predictable and repeatable builds and stable builds, because that's what you want, speedy, stable builds, is that we do a cache warm-up. Because in the experience audit, we're doing a lighthouse test, and if you're running, if your tests are being run on an AEM that doesn't have compiled client libs, for example, we saw that there was a great impact on the test suites, and sometimes also our quality gates were failing there. So what did we do if we start from the archetype? The first thing we did is, of course, we separated dispatcher config from the archetype. We have two different repos, one for the AEM code, one from the dispatcher configuration. And this is because we don't want a full AEM deploy when there is a config change in the Java code and vice versa. The other thing we did is we split out the UI content module with actual IT content, which gets deployed on specific environments. Koen will elaborate more on that. And what we also did in order to get the RDEs more reliable is to separate all the frameworks in a specific all package. In the beginning, we had just a regular all package containing all the third-party dependencies like AC tool, AEM easy content upgrade. But we noticed if we're using, for example, install hook to trigger an AC tool run, sometimes the install hooks are not correctly picked up due to timing issues, etc. So that's why we also separated that one in a separate package. Another thing we did, we checked the UI tests, and of course the archetype provides Selenium and Cypress, but we were not quite convinced of the performance there, so we started looking in Playwright, and for Playwright we noticed for the test suite that we had, we rewrote them in Playwright, and they were running twice as fast, so Playwright is our framework of choice. Another thing we noticed when using RDEs is that your test suites are always run with a dispatcher in front of it. So what we also do for our local development is to put the dispatcher in front of it and change the configuration. So how does it look like? If you open a merge request, the first thing is check if the reset is needed. After the reset, we deploy our dispatcher configuration. After the dispatcher configuration, we do the all package with the frameworks. And if that succeeds, we know the RDE is ready to receive the custom code. After the custom code deploy, we do the sanity check, the homepage check, for example, and the cache warm-up. And afterwards, we run several test suites. How those are triggered, Koen will also elaborate on that one and what they contain. Another thing we know is the code quality pipeline. Like I mentioned before, there are two steps. There's the RDE deploy on the one hand, and the code quality pipeline on the other hand. What we do there is we simply push our merge request to a specific code quality branch because, as mentioned before, there is no branching pattern or eventing. You have to assign a static branch there. So now that we all have all this information, how does this translate to the test suites and what is being run?
Yes. So now we have all the ingredients. Let's start cooking. So how does our test look like? First, we have to make a difference between sanity tests on the one hand, on the other hand, the integration tests. So the sanity tests are just a quick stability check of the environment. You just want to know if critical functionality is still working after new code is deployed. These kind of tests are already running in cloud managers out of the box. With our approach, it's also running now locally and on the RDE. One important aspect here is to note, if you need test pages for these kind of tests, these should be created yourself and deleted afterwards. On the other hand, we have the integration tests, and here we just want to do functional testing one specific part of your application, and these will only be run locally and on the RDE. The difference here is that you can rely on test pages, and for this we use a new model called IT content. And how does this look like? So you all know the UI content module of the AEM archetype. We split it up, and we changed the UI content module. In our approach, it only consists of templates and policies and sling mappings. And the biggest difference here is that we put the filter mode on replace rather than a merge. This means that all manual modifications will be overwritten each deploy, so you will ensure that all environments have the exact same set of configuration. This also implies that we locked our editable templates, so we do not allow that there are changes done to the templates, meaning that all templates are the same on all environments and we can confidently copy content over. Then we have our new module, IT content, and these consist of pages, then folders, experience fragments, and so on. And they are used to run our test against. This allows us also to, if a developer makes a change to an existing component, that he can confirm on that specific page if everything is still working. And the different aspect to note is here that it's only installed locally and on the RDE. We do not deploy our IT content module to the cloud environments. So let's look at a sanity test. So the first one is a very basic one, just checking if the site.html is working correctly. It's a very basic test, but it's just checking if the critical functionality is still working after you deploy a new code. Another example can be whenever the login button of your website is a critical part, you want to ensure that people still can log into your banking app, for example, then you put this in the sanity tests and it checks always if you add new code. On the other hand, we have a simple integration test here. It's just checking the sitemap generation process. So here's just requesting your sitemap and check if it renders. Other tests can be that all pages inside your IT content module are inside this sitemap. Other than integration tests, we also have the UI test, of course. Like Barry already mentioned, we use Playwright instead of Cypress or the Selenium WebDriver used in the AEM archetype, mainly because it's much faster. It also has different benefits, such as multi-browser support. We can use WebKit, Chromium, and Firefox all to run in a single API. And it also has a more extensive API, such as built-in accessibility testing. So Playwright is more suitable for our approach. How to run it? We simply run it in a Docker container using an internal tool developed by Adobe. It's in closed beta. It's called Evergreen as a Service. And we simply need to build a Docker image and push it to a registry managed by Adobe. In this way, we don't need on-premise infrastructure. In this way, our UI tests are run in the Cloud Manager deployment pipeline, and in the same way, it's also run locally and on the RDE. Here, also the same thing. We make a difference between a UI sanity test and a UI integration test. So this is a very basic UI sanity test. We're just checking through the UI if we can upload an asset and if it becomes available. If this isn't the case, you cannot merge your code in. Another example can be, for example, if the cookie banner is a critical part of your application, then you need to make sure that a first-time visitor gets this pop-up and you write a sanity test for it then. Let's look at an example for the UI integration test. So here we're testing our search functionality, so one specific part of your application. Here we're just going to a certain URL with a query parameter. I want to make sure that this parameter is filled into your search input field. And after other tests can also be that you're interacting with search filters and so on. So you're really focusing on one specific part here. The third kind of test we're running is light-out test. So beyond functionality, we also want to pinpoint to user experience. So we want to simulate how a page performs in real-world conditions. So then we can get feedback on performance, accessibility, and best practices and SEO. How does the setup look like? So we use our IT content again, just like I explained. So we have a test page for each component, and then we run all lighthouse tests on all these pages, and then we get component-based feedback on performance, SEO, and accessibility. Then we compare these metrics against certain thresholds, and then we can define if a certain component is good enough for us to merge in. Here in this example, you will see this image page has a poor performance score. This can mean two things. There's an actual problem with the image, or it's also always to take into account our pages have structural components such as the main navigation and footer. So take into account there can also be a problem with your main navigation, for example. So you have to strike a balance between have a component isolated case on one hand, on the other hand you want to have realistic test pages. So in this approach, using this IT content module, we can really pinpoint it to one page then. Next up, so we've talked about tests. Now let's cover the other part, code quality. So in Cloud Manager's pipeline, there's a lot of happening right now, such as the code scanning step and so on. But there also can be a problem with your code, meaning that you lose time if you deploy to code quality pipeline. It's failing, you have to look into it, and so on and so on. So you want to make sure that as early as possible, you catch these kind of errors. So here, let's focus on the code scanning results. So here your code is evaluated against a certain set of rules. For example, security, reliability, maintainability, and so on. If there's a problem with it, the pipeline will fail and you cannot merge your code in. We want to know this upfront, ideally even before you push your code. And to tackle this, we use static code analyzers locally. One big challenge here is that the rule set used in Cloud Manager is not publicly available. How did we cover this? We use three kind of tools, mainly Spotbugs, PMD, and Checkstyle. And together, they cover as many as grounds possible as the Cloud Manager's pipeline would do. So Spotbugs focusing on performance bottlenecks and null pointer exceptions, for example. PMD more focusing on really the code duplication and things like that. And we have Checkstyle, we're really checking does your code adhere to the styling guidelines and so on. One benefit of this approach is we're a consultancy firm, so we're working with different customers on different projects. With this approach, we can easily copy our rule set to the different customers and have everywhere the same process. Do note that we didn't opt for it to go to host our own SonarQube server, as it will bring maintenance costs, license costs, and so on. So this approach is more practical to use for us. We talked about code quality, but one aspect you also take into account is the architectural design of your application. You want to make sure that there is no architectural drift. So that's where we use ArcUnit for. ArcUnit is a tool used for unit testing your architectural rules. It makes sure that you enforce consistency, prevent architectural drift, and improve maintainability. So for example, if you want to make sure that a certain part of your application does not depend on packages of other packages, then you can use ArcUnit for it. You can make use of this Maven plugin, so the ArcUnit JUnit 5 Maven plugin, to really insert this kind of testing inside your CI/CD build pipeline. Let's make it more practical and look at an example. So here we do a simple check, and we see that all fields inside an add_model class, annotated with add_model, are using more specific injection annotation other than add_inject. So we want to enforce all developers in all models are using value map values, self, OSGI servers, and so on. So it's a really simple test that enforces that all models are using the same principles. Another thing that's happening in the Cloud Manager is enforcing code coverage. So whenever you want to deploy new code, you have to make sure that at least 50% is covered. So you want to avoid that once you want to merge in new code, that you notice, damn, I'm below the 50%. So how to enforce this locally? We make use of Jacoco, which stands for Java Code Coverage Tool. And using this Jacoco Maven plugin, you can insert it locally and make sure that all code is covered at least 50%, but you want, of course, a higher percentage. That's why you can also set a line level and a method level, so meaning that if a developer writes a new class, that also these thresholds are met. Let's look at the result. So where in the past we only had limited testing capabilities locally, now the result is that all tests are run even before your code reaches development cloud environment. So using this approach, we have a high standard of performance and code quality. All parts of your application are tested deeply. And using this approach results in a smooth and confidently deployment process. As last, we have also set up a reference project where we did all the modifications to the AEM archetype. So, thank you.
Questions are coming. Yeah, all right, let's get it started. How long does it take to spin up an RDE and get it ready for testing on average, like including all the dependencies, dispatcher, package installation, etc., etc.? A ballpark figure in minutes is requested.
It can take a while, indeed. In our project, where we're using this full approach, we're between the 15 minutes and 20 minutes to run all tests and all the setup is being done. So it can take a while.
Okay. Evergreen as a service. Is it Adobe Beta? Where can people join?
They have to contact Andres Bot for it. So we're using the closed beta version. So if other customers also want to participate, they should really contact him.
All right. Another question around like the timing issue. How long does it take for you to execute a full test cycle, including like integration tests?
Yeah, the 15 to 20 minutes I mentioned was to run it full. To only deploy is taking about, I think, 10 minutes or so.
Can you leverage health checks to verify the readiness of the RDE before even running the test automation?
Health checks? Which kind of health checks?
I guess system health checks. Is the RDE ready to do the testing? So
yeah, we're using the status command as said previously, but the status command is not very reliable. That's why we're doing the status of the home page. And then we start with our sanity tests, which are really smoke tests, to indicate if those already fail, there's no point in running all the other tests. So we want to fail early. That's why we're using this approach.
Makes sense. How do you test like author-publish scenarios? You could change a page, replication, validate the change on the publish instance, stuff like that?
They all can be validated with the integration tests. So you can just simply do otherwise via a curl command or via the UI. You can initiate this kind of scenarios and then evaluate it on the publisher. So it can all be done with the integration test.
Thank you. It was great to have you on stage.
Thanks.
Big applause for Koen and Barry.